Have you ever run into a situation like this before? Your cordless drill was working perfectly fine every day, then suddenly one day it stopped responding completely, even though the battery had already been fully charged earlier. Moments like this can really interrupt your work and leave you wondering what went wrong. But don't worry too soon, because in many cases the problem is not as serious as it first seems. In this video we'll slowly check each possible cause together, step by step, to figure out exactly what happened and find a proper way to fix it. And for the very first step, I'm going to test the battery using a dedicated charger to check this universal battery terminal. If the indicator light on the charger does not change color during charging, then we can conclude that the battery is currently not being recognized by the charger. Not really surprising, as expected, this battery terminal is not accepting a charge. This often happens with battery terminals that have been used for a long time, especially after going through too many charging cycles. And just to make things more transparent and trustworthy, I will mark this battery clearly so there's no doubt or suspicion of it being swapped during the process. To make it more reliable, I will take another battery that is still working normally and test it to see whether this dedicated charger has any issues. As you can see, the indicator light on the charger has changed color. This shows that the battery is being properly detected and charged, which also confirms that the dedicated charger is working normally. I will also mark this battery to ensure transparency and maintain trust throughout the repair process. For the first step, I will remove the outer casing of the battery to inspect the condition of the internal components. Normally, battery terminals that have been used for a long time will develop a layer of fine dust and faint rust marks that are hard to notice with the naked eye. Although this may seem like a minor issue at first, the long-term impact can be significant, affecting the overall lifespan of the battery. That's why the initial cleaning and maintenance step is essential. In this cleaning step, I will use a paintbrush to gently remove the initial layer of dust and dull residue. This is a WD-40 multi-purpose spray, and I will use it to clean small rust spots in the sliding grooves of the battery terminal. I've also prepared a piece of sandpaper to improve the cleaning process. The reason this works well is because WD-40 is mainly used to loosen rust, remove moisture, and break down light corrosion, but it doesn't physically scrub away the hardened layer. Sandpaper, on the other hand, provides direct mechanical abrasion, which helps remove stubborn oxidation and buildup that the spray has already softened. When used together, the spray first loosens the contamination, and the sandpaper then clears it off more effectively, helping restore solid electrical contact on the battery terminals. After sanding, I will use a cloth to wipe away the oil layer to prevent any risk of short circuits. We're not stopping here. Next, I will prepare a tool to help restore the condition of this common battery terminal that is not accepting a charge. Normally, the restoring tool works in a pair, one positive and one negative, so I've prepared 4 safety pins for this purpose. They will act as contact points inside the sliding grooves of the battery terminal. With their thin tips and decent metal conductivity, they're quite suitable for this simple restoration setup. These are 2 short single-core wires, one blue and one red, used for clear identification. One will connect to the negative side and the other to the positive side. At the same time, all 4 wire ends from these 2 cables will be attached with a safety pin, allowing them to act as contact probes for the battery terminal. With this normally functioning battery terminal, I will use it as a power source for this project. When making the connections, you need to pay attention. The positive terminal must be connected correctly to its matching point, and the negative side must also be properly aligned, otherwise it can easily cause a short circuit. In any case, this is still more of a shortcut method, so it's best to check the setup every 15 to 20 seconds until the process is fully completed. After disconnecting the tool from the battery terminal's sliding grooves, I will adjust the size of the terminal back to its original dimensions. This helps ensure proper fit and stable contact, just like it was in its initial condition. So it's a success. Now I will leave it charging until it is fully completed. To confirm whether it works stably after charging, I will test it in real operation right away. And that's it, the battery terminal is working normally again after the restoration process. Sometimes a problem that looks serious can actually be fixed with a bit of patience and proper maintenance. Hopefully this small repair tip can help everyone save some money and continue using old equipment more effectively. Thanks for watching and see you again in the next project.